Hello everyone. Today I'm going to show you a really cool project on power line communication or PLC. Now, normally we think of power cables as something that just carries electricity, but with PLC we can actually send data over those same wires. No extra network cables needed. For this project we're using the KQ-330 module, which is a tiny plug-and-play device that lets microcontrollers talk to each other through the AC mains using simple TX and RX pins. To control it, we are using the Arduino Nano, a small but powerful board based on the ATmega328P. Here's how it works. One Arduino Nano with the KQ-330 module acts as the transmitter and keeps sending a message, like hello, through the power line. On the other side, another Arduino Nano with a KQ-330 module acts as the receiver and displays the received message on the serial monitor. This simple demo proves that we can send and receive data through normal household wiring without using any extra cables. And that's the power of PLC in action.
Let's start our project. For the hardware, we'll need two KQ-330 modules, two Arduino Nano boards, jumper wires, two breadboards, two mains plug wires, and two USB cables to connect the Nanos to the computer. On the software side, we'll be using Arduino IDE version 1.art.8 and we'll also need the CH340 driver so that the Nano can communicate with the PC over USB. Now let's take a look at the circuit connections. Here we have two Arduino Nano boards and two KQ-330 modules. One set works as the transmitter and the other as the receiver. On the transmitter side, the TX pin of the Arduino Nano is connected to the RX pin of the KQ-330 module, and the RX pin of the Nano is connected to the TX pin of the module. The ground of the Nano is connected to the ground of the module, and the VCC pin is given through the breadboard to power the module. On the receiver side, the connections are the same. Arduino Nano TX goes to KQ-330 RX. Nano RX goes to KQ-330TX, ground to ground, and VCC to VCC. Finally, the two KQ-330 modules are linked through the AC mains wiring, with AC live connected to live and AC neutral connected to neutral. This allows the data from the transmitter Nano to travel across normal power lines and reach the receiver Nano through the KQ-330 modules. Here we have connected both KQ-330 modules together using the AC live and AC neutral pins. But for actual testing, we need to connect them to the real AC mains. For that, we'll use 2-pin AC cables and simply plug them into a normal electric board. This way, the data will actually travel through the household wiring, just like real power line communication. Let's set up our Arduino IDE for uploading the code. First, go to Tools Board Arduino AVR boards and select Arduino Nano. Then under Processor, make sure to choose ATmega328P. For the programmer, select AVRISPMKII. Finally, choose the correct COM port where your Arduino Nano is connected via USB. Once all these settings are done, you're ready to upload the code to your board. Now let me show you the transmitter side of our project. On the coding side, the transmitter program is very simple. Inside the loop, the Arduino continuously sends the message, hello, through the serial port every 1 second. This message is then passed to the KQ-330 module, which injects it into the power line so it can be received on the other side. One important thing to keep in mind while uploading the code is to always disconnect the TX and RX pins of the KQ-330 module from the Arduino Nano. If these pins remain connected during uploading, the Arduino will not communicate properly with the computer and it will show an error. So first remove the TX and RX wires, upload the code, and then reconnect them once the upload is complete. Now let's move on to the receiver side. The receiver program is set up to continuously check for incoming serial data. Whenever it receives a complete message, it prints it on the serial monitor. So when the transmitter is sending, hello, every second, the receiver is able to capture that same message and display it, proving that the data successfully traveled through the power line. But if we want to further reduce noise and make the communication even more reliable, we'll need to use the mode pin of the KQ-330 module, and that's exactly what we'll cover in our next video. So stay tuned, and don't forget to subscribe to the channel.